Though After Effects started out as a compositing program, creatives have utilized its toolset for creating animations and motion graphics. Duik, a free rigging and animation toolset to be used within After Effects, sought to make things easier and more efficient for the animator. Its newest and most comprehensive version, Duik Bassel, expands its functionality and refines its ease of use. Let's dive in and see what it can do. First and foremost, you'll need to be well acquainted with After Effects to follow along, so check out our survival guide on it if you need a refresher. Go to rainboxlab.org, find Duik Bassel, and download the file in the OS you're using. Unzip it and locate the folder titled Script UI Panels. Copy those files and paste them in the After Effects folder of the same name. Now we can open up After Effects, select Window from the top menu bar, and click on Duik Bassel 1 at the bottom. Let's have a look around the panel. At first, Duik Bassel presents you with the main categories of tools. Before doing anything, go to the bottom right of the panel and click on the Settings button. Under User Interface, you'll see it's defaulted to Rookie. Switching it to Standard or Expert will allow you to see more options and tools. We'll stay in Rookie for now to keep things somewhat simple, but feel free to switch it later and explore the full capacity of Duik. Go back and choose Rigging. This will be the main panel we focus on. The first tab is all different structures Duik will generate depending on your needs. Hit Hominoid to create the structure for a human-like puppet. To see how this works, let's import one of our puppets to the composition. We created these puppets with the hominoid structure in mind, each layer corresponding to a specific part of the structure, for the most part. Line up the structure parts with the rotation points of each puppet piece, keeping in mind these parts are parented from their base down. So move the arm, then the forearm, then the hand. Likewise, move the thigh, calf, foot, and so on. Once lined up, parent each layer to its corresponding structure part. Now, select all the structure layers. In the Duik panel, switch over to the Links and Constraints tab. Click on Auto Rig and IK. Duik will, again, automatically generate controllers that we can grab and move around to animate our puppet. Congratulations! You've made your first puppet. Now let's dig in and see exactly what's happening. Duik's preferred workflow involves three types of layers: the controllers, the structure, and the design. Controllers and structures are generated by Duik. The design layers are what we're rigging up, whether it's a hand-drawn illustration or basic shapes designed in After Effects. The purpose of separating it this way is A, for ease, so that you can change and update the artwork without much fuss to the actual rig, and B, so Duik can easily recognize the layers tagged as structure and controller for their automated functions. For example, let's pre-compose this entire project and name it Puppet 1. With the comp selected, go to the Controllers panel and hit Extract. Just like that, we can animate the nested puppet without having to constantly switch between comps. Now that we have a better understanding of how Duik works, let's have a tour of the entire app. Under Structures, we can create individual arms, legs, spines, and tails with the same process. Notice there are these small circles on some options. Click those to find further customization options. If you need clarification about what a certain button does, hold Shift and click the button. A help window should pop up where you can read the documentation for each tool. Next up is the Links and Constraints tab. In addition to the Auto Rig, which will work on individual limbs as well, this tab has useful tools to generate linked controllers. We'll just highlight a few. Add Bones allows you to create separate layers that control either Bezier points on your paths and masks or puppet pin tools. Simply select them and then click the button. Sure, you can twirl down and edit the actual path, but by attaching them to different layers, you can now parent points to different layers and write expressions to automate their behavior apart from the other points. Even more powerful is the connector tool. Essentially, you're linking one property to another by saying, when this is here, that should be there. Let's look at a few examples. Here we have a doorknob without any keyframes. It's simply 3 layers: the knob, the door, and this thing which is called the latch bolt. When a door is working properly, the latch bolt will retreat as you turn the knob. Let's simulate this with the connector. First, you'll need the property that will be driving the connection, the rotation of the knob. Select it and click on the circle next to connector. Here, you're given the choice between creating a custom controller or selecting a master property. We're using the doorknob's rotation as our master property, so choose this icon. We'll see how the others work in a bit. The next step is to define the parameters, or in other words, the range in which the automation should occur. In a knob's rest position, 0 degrees, the latch is extended as it is here. That's our minimum. However, to fully retract it, we probably want to turn it clockwise about 30 degrees. So let's put that as our maximum. Now we need to define the children properties, which will be the position of the latch. It's already extended, so place a keyframe here on its position property. Now skip down the timeline and set another keyframe for its retracted position. It can be 1 frame ahead or 1 whole second. Just make sure you stay consistent if your master property has multiple children. Now select all keyframes and hit Connect to Properties. You'll see a controller pop up. You can just put that to the side. Rotate the knob and notice the latch bolt is retreating proportionally. Rotate the other way and the latch bolt extends again. Now you may say that your doorknob works differently, where the latch retreats rotating the knob both ways. No worries, we can adjust this connection to simulate that. First, select the controller and go to the Effect Controls. Here we can adjust the parameters we set earlier, change the minimum from 0 to -30, and now we need to adjust our keyframes for the latch. Move the first keyframe down to 12 frames, then copy the last keyframe and paste it at the 0 frame. As you rotate between the minimum and maximum values, the connected latch will scrub through its keyframes. Let's move on to a more common example, eyes. It's useful to hook up pupils and eyeballs to a controller so you have one simple property that drives everything. Let's take this set of eyes for example. They're sized differently because of the perspective, which doesn't allow you to simply parent them to a null object. First, create the controller by clicking Create 2D Slider. We'll use this controller for the pupil's position in the eye. Select the outline and move it up to the corner here. It's a little small, so we'll select the red dot and adjust its dimensions here in the Effects panel. The process to connect a property with a controller is similar, though the 2D slider is a little special. With it, we can control 2 values, one on the x-axis and another on the y-axis. There are a few ways to do this, so let's see how this works. On the right eye, separate the position property by right-clicking and choosing Separate Dimensions. Place the pupil all the way to the left and set a keyframe on the X position. Move forward in the timeline and slide the pupil all the way to the right. Select the keyframes, make sure you have X selected as your axis, and click Connect to Properties. Now your right eye is connected to the slider. We're going to use a different method for the left eye. First, add the keyframes from the X-axis the same way as the previous eye. Notice we're not separating the property dimensions. Instead, we're going to add a list. Select Position, and then hit List under the Automations tab. Now, under Effects, we have a list. Twirl the first one down and see it contains the keyframes we previously made. To connect them to the slider, open the connector panel with the slider selected and click on the Master Property icon. Then select the keyframes and click Connect to Properties. And we've got left and right, but how about up and down? Well, we'll simply repeat the process. Set a keyframe all the way in the top for each eye, either on the Y position property or the second value property in the list. Move forward and set both keyframes for the bottom position. Now select both sets of keyframes and head to the connector. We'll need to switch the axis from X to Y and click Connect to Properties. Now we can move the controller around and see how well it controls the eyes. Connectors are powerful tools that can automate animations or consolidate several properties into one keyframeable controller. To attach behaviors to layers, head over to the Automations tab. First, the wheel. We'll select the wheel we made for this tutorial and hit the Wheel button. Now when we move it back and forth, we'll see it rotates according to its position as if it were rolling on a surface. Moving on to our spring. Press Y for the anchor tool and move the spring's anchor down to the bottom. Press S for scale, unlink the dimensions, set the Y-axis scale down to 50% and place a keyframe. Scrub forward a few frames and set it back to 100%. Now select the property and click Spring in the Duik panel. Press play and see that Duik has generated its own follow-through animation. Add a few more keyframes and see that the effect will still apply in between any two keyframes that contain the same value. Next is our pendulum. Instead of moving its anchor point, let's create a structure. Select the pen tool and place a point where you want your rotation pivot to be. Add another at the structure tip, then click Custom in the Structures panel. Now just parent the pendulum to the new structure. Open and select the rotation property and click Swing. Input some values and see it swing. Notice these automations are all expressions and are simply affecting the values of any property. So, for example, if we apply swing to the position of the wheel, it will swing back and forth. Let's do one more. We'll add a glow to this neon layer. Select the intensity property in the effect and click Blink. Press space to play, and it blinks, predictably. If we follow the same process with the Color A property, a new blink effect appears with color controls instead. Be sure to experiment with the tools, because there are applications that may not be immediately apparent, but will be exactly what you need when the time comes. Let's see if we can bring this all together. Here we have a unicycle we're going to rig and automate. Each moving part is its own separate layer. In creating the structure, we'll make one element for each, one for the body of the unicycle, one for the wheel, and a two-element structure for each pedal. Make sure you're labeling things as you go to keep it all organized. Now parent the wheel structure to the body and the pedals to the wheel, and parent the design layers to their respective structures. A great way to make sure everything's correctly connected is to select all the structures, press R to bring up all the rotations, and slide it back and forth. Good. Let's start adding behaviors. Before we do anything, let's go to the Controller tab and create our own controller. Eventually, we're only going to keyframe the position on the x-axis, so let's select this one. Move it down here, and parent the body structure to it. Now we can hide the structures away to clean up our workspace. Let's do the obvious one first and add the wheel behavior to the wheel. Simply select the structure and click the wheel automation. Check to see if it's working properly. We're close, but the wheel is definitely slipping. The final tab in the rigging panel is the Tools tab, which are just handy little tools you can use to automate small but important tasks. Select the wheel structure and wheel tip structure, then click Measure Distance. That's the radius of your wheel and the value you need for the wheel automation. Check it now and it should stick better. The next problem are the pedals. Pedals usually don't rotate along with the wheel, so we need a way for them to maintain their horizontal position. For this, we'll need to head to the settings and switch our mode from rookie to standard. That's right, if you've stuck with us this far, you're definitely not a rookie. Click Apply Changes and head to the Links and Constraints tab. With the front and back pedals selected, click on Orientation Constraint. Now they'll retain their original orientation as it wheels back and forth. Let's add some movement to the wheel. Open and select the Position property, then go up to the Wiggle button and click on its small circle. Switch the top option from Collapse Dimensions to Separate Dimensions and click Create. Now we can define the wiggle for only the x-axis. Let's put the amplitude at 200 pixels and the frequency at 1. Press space to play and see our unicycle rolling sporadically across the ground. It's looking a little stiff. Let's add a little lean to it. Select the Position property of your controller and click the small circle next to Connector. Again, choose the Master property to link it to the controller's position, but this time we'll change the type from value to velocity. This way, the connector will reference the movement of a property rather than its value. Set its boundary to -400 and 400. Open up the rotation for the body structure and set some keyframes. We'll do -5 and +5 degrees. Click Connect to Properties and press play. Now the unicycle leans in the direction it's going, giving it more life and believability. Okay, let's bring a person in. We've already gone through the process of rigging one up, so we'll speed through the process. Now we'll hide all the structures to give us a clearer view. The design layers need to be ordered correctly so that the unicycle will be in between the person's legs. To stay organized, we'll keep all the controllers together, structures just under that, and the design layers at the bottom. Now for any controller on the person puppet that's not parented to anything, go ahead and parent them to our unicycle controller. Now our puppet is moving with the unicycle, but sitting still as a board. Adjust the position of the 2 feet so that they're resting on the pedals. Now we can reparent the feet to the corresponding pedals. Let's also reparent the hip controller to the unicycle body tip. This way, parts are tethered to where they're contacting, while other parts are freely floating, and this gives the illusion that the person is balancing on the unicycle. Let's just add some keyframes of the person traveling from one end of the frame to the other, and voila! With only a few keyframes and a whole bunch of behaviors, we have an automated figure that realistically animates. Just like any tool, Duik's functionality is only limited by your ingenuity. Master it, and you'll unlock the full potential of After Effects as an animation program.